When you're caught in the rain without an umbrella, you have two options. You can walk slowly and take your time getting soaked, or you can sprint and dash through it as fast as you can, which keeps you drier. It might seem like the answer is obvious, but it actually requires a bit of thought to figure out. And it relates to something called the paradox of showers. The first thing to understand is that the rain falling on top of you is constant, which doesn't make much physical sense. After all, rain is water, and water is made of molecules. And anything that's happening to those molecules has to happen one at a time. In reality, it's the motion of countless numbers of water droplets colliding with your body that creates the sensation of wetness. And because there are so many of these collisions happening at once, we can model them all together with a mathematical equation. We just have to make some assumptions. First, we assume the raindrops fall straight down. Second, we assume they're all the same size and fall at the same rate. Third, we assume that they hit your body at random, completely evenly distributed over any exposed skin. And fourth, we ignore evaporation, which would make things too complicated. With these assumptions, we can use some basic geometry to figure out what fraction of your body is covered by raindrops at any given time. If you're standing still, it's just the area of the raindrops times the rate at which they fall, divided by the area of your body. This gives us a value between 0, where no rain is falling on you, and 1, where your entire body is directly under a column of falling water. Now, if you started running, that value wouldn't change. Yes, even if you were sprinting. That's because the same amount of water is falling on top of you as before. But here's where things get interesting. When you're standing still, you're not colliding with any raindrops from the side. But as soon as you start moving, you're moving through a shower of water that's coming at you from all angles. Each step you take adds new collisions between your body and more water, which makes you wetter. Or does it? Well, yes, but also no. Because while you're running, you're also passing through fewer total raindrops. So the net effect is that you're getting wet from the top, but not quite as wet from the sides. At this point, it might seem like the logical conclusion is that running through the rain keeps you drier than walking, right? Well, not exactly. Let's think about the whole journey from point A to point B. If you walk slowly through the rain, you're staying in the same place for longer. More rain falls on top of you, but you're also not colliding with as many sideways raindrops. If you run, you pass through the same number of total raindrops, but because you're moving faster, you're colliding with more of them per unit time. In other words, when you think about the whole trip from A to B, including the sideways rain you run into, the total amount of rain you encounter is the same regardless of whether you walk or run. The only difference is time. The longer you stay out in the rain, the more water piles onto you from above. So the answer is simple. If you want to stay as dry as possible, don't drag it out. Get out of the rain as quickly as you can. Running wins. Thanks for watching this episode, which was brought to you by a streaming service. They approached us because they knew we'd love their series, which explores the hidden math behind everyday phenomena like traffic, viruses, and pandemics, crowds, voting, and even sports. And that's just a sampling. There are 18 thought-provoking episodes to choose from. Our favorite is the one about games because it turns out there's a lot more to them than meets the eye. Some games that we didn't realize had deep math roots include rock, paper, scissors, tic-tac-toe, dominoes, and Connect 4. The math behind these and other games reveals fascinating patterns and probabilities.